Professor Bumbleweed here. Space looks peaceful, yet it's basically a freeway with invisible shrapnel. This bite-sized tour covers the Kessler Space Debris Problem, mixing laughs with real science. Relax. Narration talks, not my lips. Low Earth orbit sits a few hundred kilometers up, and satellites zip around near 7 to 8 kilometers per second. That speed turns tiny junk into bullets. One loose screw equals a very expensive oops. Space junk comes in sizes: dead satellites, rocket bodies, and millions of tiny fragments. Ground radar tracks the big stuff, but the small stuff still hits. It's like dodging hail while someone keeps throwing gravel. At orbital speed, a paint chip carries surprising punch. A larger collision is worse. It fragments spacecraft and seeds the same altitude with shrapnel. Physics stays rude. Faster objects make more fragments, and fragments make more hits. Kessler Syndrome says debris can reach a tipping point. Collisions create fragments. Fragments trigger more collisions, and the process feeds itself. It's orbital popcorn, except every pop destroys a satellite. The scary part, nobody needs to press start. LEO stays popular because it's close. Lower signal delay, easier launches, sharper images. But at a few hundred to 1,000 kilometers up, thin air barely drags debris down, so junk hangs around for years or decades. Operators regularly dodge debris. The ISS even performs avoidance maneuvers when a tracked object gets uncomfortably close. And once two big satellites smash, the catalog of trackable fragments jumps. Space safety equals constant heads up. To avoid hits, trackers measure orbits and predict close approaches, called conjunctions. When risk rises, operators fire thrusters a tiny bit to change timing. It's celestial billiards. Nudge one ball now, miss the smash later. Prevention beats cleanup. Debris rules push spacecraft to vent leftover fuel, avoid explosions, and deorbit from LEO after mission, often within about 25 years. Higher orbits use graveyard disposal. Basically, take out your trash in space. Cleanup is hard because debris doesn't sit still. Removing a large rocket body reduces risk since big objects can fragment into lots of pieces. Agencies test rendezvous, capture, and controlled deorbit tech. It's surgery at speed for garbage. If this quick tour of orbital chaos feels interesting, tap like. That signal shows which topics deserve more screen time, and it helps this channel keep making science less boring. Thanks for listening to my silent mouth theatrics. Got a topic you want explained next? Put it in the comments. Without fresh ideas, I just stand here, mouth closed, while animators stare at a blank screen. Tragic. Drop a suggestion, and I see you next time.